Don't forget the quiz is due tomorrow at midnight. If you're absent tomorrow or I forget to remind you, you're not going to get a reminder. So guys, remember, we are way too deep in this class for us to not know what's expected in this class. So please, 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 please think about when I have due dates, okay? What? Nuh-uh. Nope. For real?
Did you pick it up with it? No. I can throw it away. Get it for it. Get it for it. What's happening?
Okay. So, if anyone's watching this video and you know me, what just happened is somebody said there was a roach in the room and they got it out. So I just want you all to look at me right now and look how calm and composed I am, because anyone that knows me for real, and my last year students have heard the stories. I won't bore you with them right now if you want to hear later, but I have a horrific phobia, which is an irrational fear by definition, of roaches, like that. Okay, so what? I do have a roach escape route, and I'll show it to you guys later. But because some people don't want to hear about my roach stories, they just want to do the math.
There's more here.
That looks small from what I was saying. Where there's a baby, there's a mama.
And then you have like big mama.
Stop. Because I won't be able to get through the lesson. I'm not kidding. So I will share the story with you guys later, even today if you want, but not right now. Okay, so anyway, back to keeping calm. Isn't that funny that I chose that? Keep calm. So here we go. Quiz closes tomorrow, guys. There's no extending it. If you're absent tomorrow and then you forget, that's not an excuse. I leave it open for over a week. I even gave you class time yesterday to work on it. So please don't forget. All right. So what we're doing today in section 2.4 is taking the parent function of exponential functions and manipulating it, which is simply doing all these things to it, which we'll go over. Remember, left, guys, focus up here. Lily, come on. Left, right, up, down, stretch, shrink, flip, all that stuff. But before we get to that, let's talk about properties of exponents, which this should come as like a remembrance, a memory for you, because this is just kind of a review. But what we do need to know how to work with exponents or powers. And so the first one looks like this. When you have two numbers and or letters in parentheses to a power, I think of it as like the distributive property. You don't leave anybody out. Everybody in the parentheses should get the exponent. So if I made one up like 2x in parentheses to the third power, that would be each of the numbers inside getting that power of 3 and then simplifying if you could. Okay, so just remember, if it's in parentheses, everybody in the parentheses gets it. Let me jump to this one because it's the same idea. If you have a fraction in parentheses, you're going to give that power to both the numerator and the denominator. Like 1/2 to the second power would be 1 to the second power over 2 to the second power, which is 1/4. So the moral of the story is if there's parentheses, everybody in the parentheses gets that power. Okay? This is one that we use all the time. When you have one base and two powers, we multiply. Remember, two letters standing next to each other means multiplication. So, for example, if I have x to the third on the inside with a power on the outside, the way you would read that, by the way, is x to the third to the second. That's how I would say it, x to the third to the second, which is multiplication, and we would get 6, not 5. And a lot of people, not just students, will confuse these two right here, so be careful. The one we just went over is 1 base, 2 powers. This is 2 bases, 2 powers. When you have like bases, and that's important, the base has to be the same. So they can both be an x. They could both be a 2. It doesn't matter. As long as they're the same. When you're multiplying like bases, we actually add the exponents. You guys see this all the time with x times x. Like when you're foiling, you do x times x. You're adding the exponents to get x squared. So be careful between those two. This one we have gone over before. Remember, right over left, hug somebody. The number or letter is your inside your radicand, and then your fraction exponent has specific places where the numerator and the denominator go. The numerator goes inside as a power, and the denominator is the root. We used this one last week as an example. Oops, sorry, it was like this. It was 8 to the 1/3. Okay, so fraction exponent. The 1 became the power inside. We just don't write a 1. Okay, that's 8 to the 1st. And the cube root would be our denominator, which gives us a 2 as a simplified answer. Okay, and then the last one is how to deal with a negative exponent. This is really important. We're going to start seeing both of these a little bit more sprinkled in from here, from now and again. A negative exponent is a result. To resolve a negative exponent, you cross the fraction bar. So anytime you take something across a fraction bar, it changes the sign of the power. So you can see b to the negative n, to make it a positive n, we put it in the denominator. An example of that would be if I did this. It doesn't matter if it's on the bottom or the top. To make a negative exponent positive, you just cross the fraction bar. So since the x is in the denominator, we would move it to the numerator to join the 2, and that simply makes the exponent positive. A lot of people will think, oh, you just flip. Notice I didn't put the 2 in the denominator. 2 just stays right where it is. It's not breaking any rule. It has a positive exponent. So the x to the negative 3 just joined it, okay? I was accused of being racist once teaching this. So let me show you, because this is important that you guys understand this, but I'm going to let you guys make your judgment. So I gave an example once. I was trying to really explain this. In Algebra 2, we do like lots and lots of these. Like you really have to know it, and we give you lots of examples. And you usually have students that are confused. And so like, for example, if I did this and I said simplify it, well, the 4 would stay where it is and the x to the negative 2 would come to the bottom. Okay, and that's how you would simplify it. Notice the 4 doesn't move. I could even do this. I could even have something like, let me do this. 4 over x squared, where there's nothing that's negative, okay? But if I wanted to bring this to the top, that would change the power of the x. It would make it negative, okay? And I use the description of the fraction bar being like a boundary, a border between two countries. And one time I said, okay, so if you're in Mexico and you cross the border into the U.S., it makes your exponent positive, right? And someone's like, that's racist. I'm like, wait, what did I say? And they're like, you're saying that if you're in Mexico, it's better and more positive to be in the U.S., so you cross the border. I'm like, I don't know geography. Let's use, the only way I could describe it is Canada and the U.S. So if you're in the U.S. and you have a negative exponent and you need to make it positive, you cross the border into Canada. Just think of the fraction, seriously, think of the fraction bar as a border. If you cross that border, it changes the sign of the exponent. That's all I'm trying to say. I'm not trying to be racist. Okay, what I want you guys to do right now is pick up your calculators and try these 3. And I'm going to freeze it and put the answers up here. This symbol just is for approximately. It means I rounded my answer. I don't care if you use it. I just want you to know when I use it, that means I rounded my answer. So, guys, go ahead. Everyone pick up your calculator and do these 3, and then I'm going to reveal the answers, and you're going to check them. And you may think, like, this is so dumb. Why is she making us do this? Just give us the answers. We know how to type things in our calculators now. But, guys, I'm seeing a lot of mistakes on rounding, and you may think it's no big deal, but it could be the difference between a point or not on an exam or on my test. Rounding is a big deal. And I'm not trying to insult your intelligence, because I know we learned how to round at a very young age, but we don't have to use it that often, so we forget. So listen, as you're putting these in your calculator and writing your answer as correctly as you can, be thinking, once I reveal the answers, if you are consistently making mistakes with your rounding, like you're noticing your answers are off by like 1 digit or something like compared to mine, please find some time to talk to me before the end of the year, because we need to go over that, and I have easy ways of explaining to you it. No shame in your game, no big deal. Let's just fix the problem, okay? You'll have a chance to practice more in the homework if you were a little slow getting started there. But make sure you are rounding correctly. Said to 3 decimal places, those are the only answers we should be getting. Okay? Questions? All right. Last week, we started talking about the most basic form of an exponential function, and we graphed a few of them. Here, we're just going to review what we already know about exponential functions. Notice they left off the a here. Sometimes we call b to the x the parent function, a times b to the x the parent function. It doesn't really matter. It's not going to change anything that we talk about here. Wait, these three? These are the same. Okay, so this one is just saying a is 1, right? They're just not putting a negative number there or anything. All of this that we're about to talk about refers to whether you call this the parent function or this the parent function. It's not going to change anything. I know that's a little confusing, but I promise you won't be once we get going on it. Okay, I want to remind you that in the exponential function, before we do any of this stuff to it, before we do all of the transformations, the domain is all real numbers, and the range is from 0 to infinity, not including 0, right? That's what we learned last week. Remember, it was over and over again. The range was 0 parentheses to infinity. That will start changing, but the domain will always be all real numbers. No matter what we do to the parent function, the domain of an exponential function is any positive, negative fraction number you want, okay? The basic one has these have a y-intercept of 0, 1. This is important. When b is greater than 1, it's increasing. We learned that. Remember, when b is greater than 1, it's rising left to right. They're always continuous. And in this case, if you're rising as you go left to right, you're concave up. If b is less than 1 but greater than 0, in other words, not negative, b will never be negative, but 1/2, 7/8, 3/4. Those are all numbers less than 1, greater than 0. It's decreasing, continuous, and still concave up. Remember, it made like a backwards J. We'll see all this in some examples here in a second. We have a x-axis, that is our horizontal asymptote. The x-axis is y equals 0, right? Horizontal line. And don't worry about number 6 for now. Okay, so let's go back to graphing. Let's graph f of x and g of x on the same coordinate plane, and then we'll talk about it. So starting with f of x equals 2 to the x. What we're going to do is make an xy chart. And anytime you're doing any graphs and you're making an xy chart, these are typically the numbers we use. We can always add to it if we need to, but those are a great starting point. Some to the left, some to the right, and right in the middle. And as I showed you last week, I like to start in the middle because anything to the 0 power is 1. 2 to the first power is 2. 2 to the second power is 4. And really, going backwards using the negatives, it just flips whatever the positive answer was. So if 2 to the first power is 2, 2 to the negative first power is 1/2. You just flip it. 2 to the negative 2 would be 1/4. So it makes it really easy to fill in that chart. This is going to have a horizontal asymptote right here. I always like to put my asymptote in before I graph. It keeps my points within where I want them to go. And here's a faster way to graph, okay? Start with your 0, 0, 1, and go to the bigger numbers, 1, 2, 2, 4. Because then you know the other two, these little ones, are just these teeny tiny numbers that get close to 0. You can't graph them exactly anyway. Now you can start to see the curve of this. It's going to look like a J. This is a situation I would choose maybe one more number to give it more of that curve, more of a guide for my continuous graph with arrows on the ends, not touching or crossing the asymptote. Okay, so sometimes it makes sense to add maybe one more number to give your graph a better look. Okay, let's graph g of x is 1/2 to the x. So this one is going to be decreasing, right? The numbers are getting smaller. I'm going to go ahead and use the same numbers. Starting at 0, be 1. 1/2 to the first power is 1/2. And remember, 1/2 to the second power, that was the example I used up here. You apply the 2 to the numerator and the denominator, which gives us 1/4. Then when we go in reverse, you just flip it. So if I flip 1/2, I get 2. If I flip 1/4, I get 4. So -2, 4, -1, 2, 0, 1, and then you get those really small numbers. So you can just do those kind of quick. I don't really like how short my J is, so I'm going to add one more number. I don't need +3. I know where that's going. Let me get one more point over here, which would be 1/8. No, 8. Sorry, thank you. To the left 3, up 8. And here? Is that what she's talking about? Yeah, I know it's out of order, but I didn't give myself room. Doesn't matter. And there would be that graph. So you might notice that these are reflections of each other, reflections over the y-axis, okay? Because, remember my talk about being racist? I'm going to write 1/2 to the x a different way. I'm going to bring the 2 to the numerator, okay? So you know in algebra, there's a lot of times that we manipulate things. We change things, but as long as we follow all the rules, we are allowed to change things. Like slope-intercept form, like we can take any equation and move everything to one side as long as we follow the rules, okay? We can change fractions denominators as long as we change their numerators. So there's all these rules that we follow. So for example, let me not make this a fraction. I want to bring the 2 to the top. Right now, my 2 has a power of 1 in the denominator, right? 2 to the first power is 2. If I cross the border, cross the fraction bar, the power of my exponent is going to change to a negative. So it's going to bring it to the top. So there's a 1 already hanging out there, and then that -1 times x. So what you really get, which is equivalent, is 2 to the -x. These mean the same thing. I just brought the 2 up and it changed the sign of its exponent. Now, what does that mean? Well, we're about to go over it, but I wanted to make a point. Whenever you have a negative in front of the exponent, that's a y-axis reflection or flip. And that's what happened. We just didn't know it was going to do that with the way it was written, okay? So just hold that thought for a second and let's look at the next page. And I'm going to go through this chart pretty fast, okay? So if I go too fast and you feel like you need to go back and look at it, you might want to dog-ear this page or put a Post-it note on it because these are rules that we live by with transforming graphs, and we've seen them before. These are in your Unit 1 notes somewhere as well, same exact thing pretty much. It's the same rules that we can apply to any parent function. And the first ones that we're going to talk about are vertical and horizontal translations. Those are your shifts, left, right, up, or down, okay? K and H. Notice when we have a vertical translation, known as K, it's going to be all the way far to the right of your function. So this is up K, this is down K. What does it look like in an exponential function? Pretty obvious. It's the number all the way to the right. It's not opposite. So this is shifting or translating up 4, down 5, okay? We have to know by where a number is standing what it does to the graph, okay? H is the one that's opposite, if you remember. Anything that has to do with X or horizontal stuff is wonky, and H is always going to be somewhere sequestered off with his bestie X. In a parabola, it's in parentheses, for example. Here, it's going to be up in the air, hanging out with X, because that's where your X is in an exponential function, right? 2 to the power of X. So anything that has to do with left or right is going to be up there with that H, up with that X. And it's opposite, right? Minus means right, plus means left. That's not changed since Algebra 1. So you can see right 3, left 6. How do I know it's right or left? Because of where the number is standing. How did I know these were up or down? Because of where the number is standing in the function, okay? Then we have our vertical and horizontal dilations. We've called them stretches and shrinks for many years. You can still call them stretches and shrinks. I like dilation better. It's a more varsity level math word, and it's got the double bonus of you don't have to worry about is it a stretch or is it a shrink, because dilation covers both, okay? And you know if it's a vertical stretch or shrink, and we should be putting whether it's vertical or horizontal in front of this word by where the number is, and that's the A value. That A value, that is your y-intercept, also gives you your stretch or shrink, okay? And you don't do anything different to it. It's a dilation, vertical dilation by factor of 3, vertical dilation by factor of 1/2, vertical, okay? There's that weird horizontal one. These have to be flipped. Remember, these are the ones, this guy and this guy, you have to be careful of. Anything to do with that horizontal stuff is wonky, okay? And so if you were plugging numbers in, like you made an XY chart and you had to plug into these, you just do whatever math it says, 1/4 times -2 or 3 times -2. But when you say it or write it, you flip it. So that's really a horizontal stretch by 4, a horizontal stretch or dilation, shrink, by 1/3. So remember, those are the two. You're pretty used to this one. You guys have been using that opposite thing for many, many years, but this is the newer one this year, okay? So this one be really careful of. And then reflections are flips, right? We just did one a second ago. When the negative is up in the air with the X, it's actually a y-axis flip. And when the negative comes right after the equal sign, it's an x-axis flip. How do I remember that? Let me pass it on. I know for an x-axis flip, I know what parabolas do. When it's a happy, smiling parabola, it's above the x-axis. Think of it like that. The minute you put a negative in front of it, it makes it a sad parabola. What did we just flip over? The x-axis, okay? So the negative in front does the same thing to a parabola as it does to an exponential function. It flips over the x-axis. The negative up in the air flips over the y-axis. Okay, we need to know those. I think we know most of them, or all of them, but they're really, really important. They keep coming up. All right, almost there. We are going to graph f of x and g of x on the same graph. Let's make a table of values. Again, anything to the 0 power. Oh, I forgot to tell you something important. Sorry. Back up here. This is really, really important. The k value affects your horizontal asymptote. So your horizontal asymptote is y equals some number. It's always going to be the k value. Think about it. If you move all your points up or down, it's also going to move your horizontal asymptote up or down. Okay? So what has k been in all the other examples? Well, it was 0. Right? There was no number to the right. There was no number. So our asymptote was just k was 0, so y was 0. We don't even have one in our notes that does a different number, so I'll do number 10 in our homework with you to do one where the asymptote changes. Okay, I'm getting ahead of myself. Okay, so 3 to the 0 power is 1, 3 to the first power is 3, 3 to the second power is 9. Flip them. You can't even do that in your calculator that fast. Okay, so let's go ahead and graph this. My k value is 0, so I'm going to have my horizontal asymptote right here at y equals 0. And 0, 1, 1, 3, 2, 9, and then my little numbers over here. And I don't need to add to my XY chart. This is a very nice curve. I can really clearly see the shape of the graph. Great. Okay. Increasing, concave up, continuous, all those things you could say. Now, instead of making an XY chart for this, let's take these points and do what with them? What is that plus 2 going to do to all of our points? Wait, what direction? Right? Remember, if you're up in the air hanging out with X, that's your horizontal and its opposite. So all of our points are going to go left 2. Again, just do your whole numbers, like your easy ones to graph. Like right here, it's super easy to go left 2, left 2, left 2. And then, you know, these other ones are just going to be these little tiny numbers, getting close to the asymptote. Same shape graph, same size, just all the points shifted to the left too. Same asymptote, whole thing. Okay? That makes sense? Yeah. Last question. This is the very last homework problem that you have to do. And it's kind of cool. And this is probably the only new thing you probably have never seen before. Not difficult. G of x is what we just had right here. Same thing. There's a way to rewrite this in this form, meaning without the transformation. We're going to rewrite g of x equals 3 to the x plus 2. We're going to write it as h of x equals a times b to the x. How are we going to do that? It's really, really simple. It goes back to one of our properties of exponents. Let me write it here. This property right here, when you have like bases multiplied together, we add the exponents. So really, we're working in reverse here. What we have here is our b to the m plus n. It's written in this form. Let's go backwards. Let's split it into two like bases, so 3 times 3, and then m and n, x and 2. Finish it up. How? Really simple. 3 to the second power. Let's put that in front. And then the b to the x. It's now in a times b to the x. Guys, these are the same thing. If you put them in your graphing calculator as y sub 1 and y sub 2 and graphed them, they'd be right on top of each other. They'd have the same xy chart. It's two different ways of writing the same problem. So if you're having trouble seeing it, work in reverse. Like, do what you think is right and then say, okay, does this match this? Oh yeah, keep the base of 3, add the exponents. Kind of neat. So you would have a y-intercept of 9. It would be I just threw my pen. I don't even know where it went. Oh, it's there. Okay. I think I wrote on my face. See, I get a little jittery about the whole roach thing. You'll understand why. Do you remember, Evan? Alessi? Sam? Do you remember? Yeah. Okay. Yeah. It's a good story. I'll share with you later. Kirk, do you remember my story? About roaches? Yeah. Okay. A lot of you I had notes for too. All right. Let's go to the homework. And I'm going to do number 10 with you. Friday was B5. 2.3 was B5, guys. All right. I'm going to do number 10 with you. Guys, do number 10 with me before you leave me. We are going to graph this using an XY chart. Notice, guys, look. Notice I'm only graphing the b to the x part. If there was an a in there, we would include that. Okay? So I'm only plugging into what I boxed. But be careful, we haven't had one that had a negative in front before. This would be 0, 2 to the 0 power is 1, but there's a negative in front, so that makes it negative 1. 2 to the first power is 2 with a negative in front. And 2 to the third power is 8 with a negative in front. And then just flip your negative 2 to negative 1/2. Flip 4. Sorry, it's negative 4. Thank you. Didn't I do that just earlier today too? And then negative 1/4. Okay? So I'm going to go ahead and, okay, let's now, before I graph that, you have a choice. You could go ahead and put this on your graph as a parent function and then do this to it. I'm going to do it all at one time. What does that plus 3 do to all of these points? Up 3. That's also your k value, guys. You're going to have a horizontal asymptote now at y equals 3. The k affects your asymptote. So we have an asymptote at y equals 3. I always like to put it in before I graph. It makes the graphing easier. So now I'm going to do it all in one graph. You could do 2. You could do parent function and count up 3. I'm going to go to these points, hover, and then count up 3. Okay? So 0, -1 is right here. That's my parent function, but I know I have to move it up 3, so I'm just going to count up 1, 2, 3. There's my y-intercept. Okay? And I'm going to keep going. To the right 1, down 2, and then count up 3. To the right 2, down 4, and I'm going to go up 3. And then you have your little numbers here. I don't even need to really look at them. But I am going to add one more because I think I need more of a curve, and that's where I will get my -8. So to the right 3, down 8, and then don't forget to go up 3. There is our decreasing concave continuous graph with a horizontal asymptote at y equals 3. It asks for a bunch of stuff. It asks for the asymptote. There it is. It asks for the y-intercept. There it is. And it says is it increasing or decreasing? This would be a decreasing graph. It would be concave down. Okay? So that's what it means. Listen, one more thing. That's what it means by hand. So do these two by hand. If you want to do the rest of them with your graphing calculator, that's fine with me. Sometimes it's faster to just do it by hand, but it's up to you. So you could type this in your graphing calculator and get an XY chart just from typing it in y sub 1. Okay, so you understand how yeah. So I put 0 in. Two of the zeros are but there's a negative in front, so that's how I got that. 2 to the power is 2, and then 2 to the third power, because I did that going further, is 8. Then if you want the negatives, you can split it. So if I flip -2, I get Sam, are you friends with Julia? I just heard that contaminate.
She can do them like under the table. Only with the 2x2. She was not. She didn't tell me that. Only with the. I tried to do it and she can't do it. I can do that. Alright, social people working. Oh, you should hear your little story. I don't hate religious experiment, and I feel like I'm going to throw up when I see one. Because, all right, if you guys want to hear the road story, I got to stop recording because it's pretty unprofessional to talk about.